Hi guys, what we're going to look at today is solving absolute value inequalities. Now, the nice thing about this is that it kind of takes what we've been doing with the compound inequalities and the absolute value equations and merges them together in this topic. So I feel like as we go through this, things will be good because the last two things that we've covered, you'll have some familiarity with how we solve this. All right, but the first thing I want you to look at is that question. What does the absolute value of x being greater than 4, what does that mean? Well, if you think about it, that means that the answer that we're looking for, our x, has to be greater than 4 spaces from 0. Now remember, we talked about this. It could be 4 spaces from the left or 4 spaces from the right. So technically, if the absolute value of x is greater than 4, it means it has to be 5, 6, 7 and keep going that way, or negative 5, 6, 7 and keep going that way. But really, it means if it's just greater than, that's an open circle at 4, and everything going this way, all these things have an absolute value greater than 4, but everything on the left, from negative 4 going that way, also have an absolute value greater than 4. These things are more than 4 spaces from 0 on the number line. Now in contrast, look at the next one. What does the absolute value of x is less than 4 really mean? Well, that means that the number we're looking for is less than 4 spaces from 0. So if you think about it, it's going to have to be somewhere between positive 4 and negative 4, again with open circles. So it's going to have to look somewhere between here. These are the numbers that all have an absolute value less than 4. They are less than 4 spaces from 0 on the number line. So here's my question. Do you notice anything? Do these patterns look familiar to you? They should. Okay, if you look back, at the first one we just looked at, what does this look like to you? This looks like our typical OR graph from compound inequalities. Now we know there are exceptions, but this looks like my typical OR. Versus this one, this looks like my typical AND graph from compound inequalities. So like I said, you will see these similarities, and we'll talk about this, about how these less than and greater thans really relate to and ORs from compound inequalities. So the chart that you have on the bottom, a little bit more formally. If the absolute value inequality, once you get absolute value by itself, is a greater than. So if we are looking at a greater than symbol to begin with, this breaks down into an OR inequality. Now, the one thing that you need to look at when we create the second case, you're used to creating this second case about what if the thing in the absolute value is to the left or the negative option, but look what happens. The sign also flips. So for an example there, if I had initially the absolute value of x plus 3, terrible 3, there we go, is greater than 1, absolute value is by itself. Because it's a greater than, this breaks into an OR. And the way I'm going to set this up to solve is I'm going to say, okay, when I break this into my two pieces, either x plus 3 really is greater than 1. It's more than 1 space to the right. Or x plus 3 is less than negative 1, meaning it's more than 1 space to the left. In contrast, when I have a less than to start with, this breaks into an AND inequality, okay? So same idea of the sign has to flip when I talk about the negative option or the option to the left, but this becomes an AND inequality. So if I have absolute value of 4x minus 1 is less than, close it up, is less than 7, when that breaks into my two pieces, that means that either the quantity 4x minus 1 is less than 7 on the right side, but this means an and 4x minus 1 is greater than negative 7. So that's the big difference. But honestly, once you get that, when you go to solve these, this is just like solving compound inequalities. So it's really nice that this section is kind of the past two sections rolled into one. It kind of helps us review everything at one time. So it's a nice thing for us. Okay, so let's walk through this first one together. So again, very similar to absolute value equations that we talked about on Friday, that if absolute value is not by itself, we have to do that first, okay? So when you see this 2 in front, remember, we cannot distribute. We need to get rid of it. So we need to divide those sides by 2 to start. And then we're looking at the absolute value of x minus 4 is greater than 4. Okay, now I'm ready to break apart into my two pieces. That either x minus 4 really is greater than 4. It's more than 4 spaces to the right. And because this is greater than to begin with, this becomes an or inequality. And my other case is that x minus 4 is less than negative 4 because it's more than 4 spaces to the left. Okay, then I just need to solve these. These are both a pretty quick one-step solve. So we're looking at either x is greater than 8. Still an or, that's not going to change. X is less than 0. Okay, now think about how we graph these ors. Ors say graph everything. So if we're looking at, I'll put 0 down here, it's over here. Okay, remember, ors mean graph everything. Give me all the solutions at the same time. We talked about this when we did these compound inequalities. If you want to draw on top to kind of see this visually, great. If you don't, that's fine too. But if I'm doing this, this one would be an open circle at 8 to the right. That takes care of my first piece. My second piece would be an open circle at 0 to the left. Now, if I'm writing this interval notation, remember, that's based off solely off the graph itself. So I read this from left to right. I start at negative infinity. I go to 0. It's an open circle, so I get this parentheses. There's a second piece here that starts at 8 and picks back up to positive infinity. Again, I hope that this is a nicer view of these compound inequalities for us. Okay, look at that second one. Now, like we said previously, I cannot do anything with this until I get absolute value by itself. It's not by itself. So I definitely have work to do. So my first step is going to be to add the 1. And then remember, I can't distribute that 4. To get rid of it, I have to divide by it. So now I look like the absolute value of x plus 2 is less than 3. Okay, now absolute value is by itself. And honestly, I don't care if we're in equations or inequalities. Once absolute value is by itself, that's when I can set up my two cases. So this is the point where I'm ready to say, okay, either the quantity x plus 2 really is less than 3. Now, this is a less than to begin with. So less thans become and graphs. So either x plus 2 is less than 3 and, so at the same time, x plus 2 is greater than negative 3. Okay, now I have to solve both of these. But once I get these set up, these solves are pretty quick. I mean, most of the time they're 1 to 2 steps. The first one gives me x is less than 1. And x is greater than negative 5. Again, and graphs talk about what we have in common. What part of the number line is a solution to what I have in red and what I have in blue at the same time. So when I talk about graphing these, I'm going to put negative 5 here. Okay, just like when we did these with the compound inequalities, if you feel like you need to draw on top of it and see where these solutions are at the same time, great. If not, that's fine too. But this final answer ends up looking like an open circle on -5, an open circle on 1, and they are graphing in the middle. Again, if I look at this interval notation, it's from the graph itself. This answer starts at -5. The open circle gives me some parentheses, and it ends at +1. Okay, so what I want you to do is try number 3. So go ahead and pause the video, try it, and then check it with me.